Hello, my name is Jochen Teizer. A little bit background to myself. I'm a professor at the Technical University of Denmark in the Department of Civil and Mechanical Engineering. My research and teaching focuses on information and communication technologies, construction safety, health and well-being. My work is funded by various organizations, including the European Horizon 2020 program. I have achieved my learning outcome. Today, if I get three key messages across. One is prevention through design and planning. Second, proactive feedback. And third, active learning environments. The motivation for my research is multifaceted. The industry faces challenges, and I'm not going into those details about productivity, emissions and waste, an aging workforce. But mostly related to this presentation is the content and the methods that we have available for work. The current safety management practices are not really built for the digital world that we live in. They're stale, they're static, they're often not meant for interdisciplinary work experiences. And this is the reason which brings me to the topic of zero accidents. And we all want to achieve it. And as we have heard probably earlier, safety statistics is a very delicate topic. We may not be able to rely and trust them fully. However, they give good indications of the current state of safety in our organizations. I typically like to show this graph because it shows us safety has been improving over several decades. However, in the past couple of years, it has been stagnant in reducing accident numbers. We also know that we have shifted focuses away from lagging towards leading indicator and data collection, and recently also towards prediction. I'm a big fan of proactive safety that actually tries to prevent injuries in the first place. And this is where digitization comes in. It should be seen as an enabler and not as a replacement of human skills. This is very important. Maybe a little bit on safety in Denmark. Denmark has a much smaller economy, and still we experience 5 fatalities every year. A lot of apprentices are involved in accidents. The Nordic countries in particular have overall better safety records than many other countries around the world. Of course, we know we have high-level control theories from the owner and the organizations buying it into safety, all the way down to providing worker training, safe work environments, and personal protective equipment. And that's why we need to embrace the term digitization. I have added this as another layer of protection, and I think this is a good way of enhancing this diagram that was established about 30 years ago. And why is that important? Because we still see these in infrastructure projects in Europe. Railway construction on the left-hand side. This is a whiteboard where we coordinate equipment and work crews as they replace rail tracks. On the right-hand side, you see an embankment of a bridge. And even though we use building information modeling, model coordination is a big challenge. Actually, 2 design crews have actually modeled a guardrail, one of completely off, the other one almost perfect. But we see this all the time when we deal with building information modeling. And the reason is it's done manually and not really in an intelligent way, requiring a lot of rework, wasting resources. We want to invest somewhere else. The current state and roles of occupational health and safety in BIM, unfortunately, does not have yet the prominence than other specialties have in BIM. There's no systematic approach where lessons learned and good practices are being shared using BIM for occupational health and safety, or prevention through design and planning. Often, there's a lack of statistical-based instrument and databases that support which areas to focus on. As you can see here on some of the surveys that were conducted, safety does not really play a role in the BIM guidance documents. As you see here in Germany, it's meant a little bit in the planning and the design phase, but it doesn't appear at all in the operational phase. Well, that has to change, in my opinion. Recently, the term digital twins has come up, and I like it because it includes this dynamic character of also involving the construction phase. So let me introduce you my thoughts on digital twins for construction safety. First of all, construction safety requires a double transformation. First, safety is top-down typically. It's linear, and I think we need to embrace a circular approach. And secondly, all of our experience-based safety management is great, and it has shown effect in the conduct of safe workplaces. However, we also need to move away and towards evidence-based safety. Let me explain to you this chart I have created 15 years ago. Back then, nobody called it a digital twin. This is a construction site. We want to actually utilize building information modeling for designing out hazards, because we have many rules and best practices that we can simply apply to building information models. We want to assign workers and give them experience-based certificates to carry out work, provide them with the adequate temporary equipment to ensure their workplace is safe, and give them the right instructions and the time and the positions where their material and themselves have to be. The trades then also have, of course, smart mobile devices to record the actual status of the project or the task they are performing, but also report back if any issues arise, to report a close call. We can debate whether this should be done through a mobile interface like a smartphone or not. Some allow it, some do not. In the end, it doesn't matter. You can still use reporting cards if they are convenient for your organization. However, think about the aging workforce and the one that is coming right after. People like to use mobile devices. Now, this information is actually being recorded, preferably in an automated way, and shared with the safety and construction management. So from actual data, we go all the way towards information. So we get raw data converted to information, but information yet is not really useful for us because we would like to get knowledge to improve our next project. But we don't want to forget, we want to also treat our workers nicely. Well, why don't we start doing that actually and giving workers additional training? Thinking about active learning environments where they get personalized feedback. And this is what we try to do here as well, using, for example, virtual reality, but also 3D, just 3D games are often just enough. So this lessons learned from the project as well as from training environments can be fed back to generate the next safe project. So this is in a very graphical and simplistic way what we want to do. I'm not reading out this slide. Think about this vision that we have, a manager that knows the real-time status of everything, of course, of safety as well. And actually not just the safety manager, but all people that are concerned, including the workers, giving them access to reliable, personalized, accurate safety information. So everybody has that situational awareness. That's the beauty about a digital twin. And the technology, honestly, it's almost there to get that done. So digital twins, you know, this is a replication of the real world and streamed in a digital world, but not just to visualize on a screen in 3D what the real world looks like. No, it's more than that. It actually is there to predict and avoid future accidents from happening. Now I see three phases in our occupational health and safety digital twin here on the right-hand side. There's the digital design and planning. We have the proactive risk monitoring and control. So preferably, I'd like to take the planning effort and actually give workers right time alerts if they go into a hazard. And last but not least, this personalized feedback that's essential to close out on this circular approach. Now, let me show you a couple of examples what we do with prevention through design and planning. I think this is what you mostly will look for. This is a manual effort of designing out fall hazards in an apartment construction building. We have a balcony where guardrails have to probably be installed. We have actually automated that way by coming up with an algorithm, and we actually have methods to model these right away with the schedule. And this is a big savings in terms of time, also avoiding mistakes. For example, all of these little yellow plates here are hole covers. You probably would experience them on a job site and then simply cover them, but you can do that already in BIM if you apply such safety rule checking. The difference here is this is in the view of a single person or maybe a few single persons. Here you have an entire team, and leveraging this interdisciplinary approach everybody wants to have in construction projects. So it's really nice, and we've done that with multiple contractors of enhancing the safety performance. You see here a video on the right-hand side without guardrails that have been automatically modeled. On the left-hand side, you see it. Well, if you think about clash detection, it's very similar to that in building information modeling. We have safety rules. These safety rules are applied to the model. Here we have a benchmark model with various cases, various challenging cases for the algorithm at least. You see here, this is the raw model, and here you see already the guardrails that have to be applied according to certain rules. For example, in this little space, you're not supposed to work because it's too small for you to work effectively. So there's a lot that goes into actually extracting the geometries and extracting workspaces and fall spaces. Another example for safety rule checking for infrastructure projects this time is a subway station. Again, it relates to fall of a shaft that you see here on the right-hand side. Other examples for construction site layout plans, here you can see that cranes are too close to the excavation pit according to the safety rules that exist in Germany. They need to be moved a little bit back so they don't fall into the pit. Here on the right-hand side, you see internal traffic controls plan that can be created, separating worker paths from vehicle paths. Again, where are those safety plans that do that automatically? And for every project, it would be a dream to have that. Even here, temporary storage areas where you see crane swings occurring, crossing a pedestrian pathway. Well, you have to come up probably with alternatives. And this can be done easily once you start applying safety rule checking. With our friends from the lean construction domain, and you guys are very good in terms of creating productive work environments, but where's your approach of involving safety and getting this done in a quick and fast manner with building information modeling? Again, here's a plan that was done manually in 2D, and here is one that is being done using building information modeling. Still very rough, but again, a first indication of getting your job site safely organized. Now let's move to the next step, conformance checking or compliance checking. Let's stick to this example of guardrails. We have here a raw model. It would be beautiful if every project would give us the requirements for fall protection, whether guardrails or hole covers or other temporary assets that are needed. That, first of all, doesn't exist based on known safety rules. Now we can actually apply also tools like drones or photogrammetry to collect and generate point clouds, and then apply other algorithms that can check where discrepancies occur. As you can see here, we have another model generated based on certain elements where we removed guardrails and then flew the drone in a simulated virtual world. And the algorithm actually can detect all of those issues. A next step will be to fly the drone in reality and compare to the original safely planned model. And I trust and I'm very confident that this will create big success in terms of getting safe modeling and safety monitoring actually done. It's not challenging with the tools and technologies that exist today. Here is an approach of augmented reality. Here you see an engineer. She actually uses a smartphone to detect that there is a guardrail missing. She actually manually takes detects it and asks, well, something should be there. And she draws the information, pulling it live from the cloud. Now let me move to the third part, runtime safety monitoring and alerting. We have also looked into the feedback chain. When close calls occur, typically the workforce sees or experiences it, they report it, and maybe it gets entered in a database, and maybe then there's a peer review team in certain organizations that exist that report it to the corporate or local management. And at some point, somebody will make a decision and it will come back to the workforce, but most often it does not. It's very discouraging. And here we thought about deploying technology that actually uses smart sensors that can also report, in addition to a human, such situations and process the information to the involved stakeholders and generate feedback that is then more encouraging to the workforce to continue. How does this work? We were among probably the first to deploy tracking technologies on workforce, maybe just for short-term monitoring. We want to also ensure the GDPR requirements in every country, of course. But it would be cool to actually deploy such technology on a regular basis to give people a sense, hey, we care about you. We really care about you, and give them feedback. Are they actually performing well or not? And so far, we had very good experiences with unions. For example, in the United States, in the UK, or even Germany, they actually embrace sometimes the use of such technologies. But regardless of that, in building information modeling, we can very well define work areas and hazardous areas. For example, here an area where a mobile crane is wheeling steel girders into place, and there is a masonry crew working, and this masonry crew actually has to travel to a saw. As a matter of fact, we see already some issues with site efficiency. On the other hand, as you can see here, recording all the trajectories, we see a lot of proximity events where the crane load got somewhat close to workers. Now, in such a case, such a job site should be probably temporarily halted, and people should be made aware of this issue, that there is two competing work crews. Again, all of those red dots indicate a proximity between the crane load and the worker, not necessarily a close call, if I may say. Now, this was done actually with radio frequency-based technology, wireless, not RFID tags, but ultra-wideband technology. Actually, you can also use vision-based cameras. Here, we track the productivity of dump trucks arriving for an excavation project in Munich, downtown Munich. On the right-hand side, you've seen already a tower crane camera that is installed on the trolley, watching downwards. And actually, in our research, we are well able to actually detect and track workers being too close to the crane load. It's absolutely fascinating of what technologies exist that we can leverage for safety purposes. I don't have the time to go into those details. We have done a lot of work with blind spots or blind spaces, as a matter of fact, for equipment operators. We have developed and worked there with companies very early on that typically work just in underground mining operations to bring this also to above the level. And yes, several of you have experienced it and may criticize the use of such variable tags. And absolutely correct, they have benefits and shortcomings. But in certain situations, some of these approaches actually have a lot of impact. You can see here a variable tag that notifies a worker when they get too close to a machine. Actually, there are certain zones you can calibrate, and as soon as they enter, maybe the worker gets an alert or the equipment will be slowed down and stopped. Anyway, a recording can happen, logging this data, maybe complying with all the GDPR requirements, because we're not interested in knowing who necessarily it was, rather than the information about the event. I show you a test we have conducted, showing you that actually this technology works. Here you see an image of a terrain model. The BIM model has been superimposed. And on top of that, we have visualized the data, and this is happening in runtime. Anytime an event occurs, you see here a little cube appearing. If the cubes accumulate in certain areas over a certain threshold, they turn into a different color, yellow or red. Here you see the parking space that was also traversed by equipment. They had an issue there. Then they separated the walk spaces of the pedestrian workers from the other traffic. And suddenly it didn't occur here anymore. Same over here on this part of the site. But for workers themselves, you may have a feedback card, maybe on a weekly basis, telling them, look, this is how often you got too close to an equipment. A project we have done in the Swiss Alps with a contractor provides the technology that works reliably, especially in such environments. We have done this also with a contractor currently in our European Union funded project, where we record data about machines in railway construction. There we predict the movement of machines as well as the proximity to workers around the vehicle, or the reach of the vehicle into neighboring railway tracks, which should actually not occur. In this particular case, the track is completely under construction, so it's not a problem. Last but not least, let me come to this point of advancing our existing learning styles. We all know this, and I participate in those toolbox meetings myself, or even mock-up safety training sites. I very much like if those exist, but it's rare. You need a certain size in a project that happens. Actually, we want to get away from some of the top parts here of how we learn, like reading text or attending a lecture. I'm not necessarily saying that virtual reality is the way to go. Challenging for an experienced workforce. For the younger generation, they typically embrace it quite well and quickly. Of course, there's issues with VR sickness. About 10 to 15% experience it, whether they acknowledge it or not. However, we have created more than actually virtual reality. We have actually created augmented virtuality. This is a slightly different term, because we actually augment the virtual reality with devices that you hold in your hands. And we simply gutted it, made it dysfunctional, but made it functional for the virtual reality experience. So actually, when you turn on the button of the angle grinder, it actually turns also on in this virtual reality scene. And the case here is actually a true case where we experienced in Germany in a chemical processing plant a fatality where a worker cut into the wrong pipe, and I think it was 4 or 5 workers who got killed instantly. As you see here in this video, the participant here actually turns on the angle grinder. Now you see only a part of this setup. The entire scene includes multiple hazard recognition and rectification exercises. This environment that we have created is actually built on a building information model of a shop floor or machine shop that relates to oil and gas processing facility. And workers are being trained to recognize certain hazards, making sure the workplace is safe. It has shown effectful for workers to get such training. What we do is we don't use virtual reality as a visualization. We take virtual reality to collect data about the participants as they experience these unsafe and safe virtual reality environments. You can see here little dots. All of them are visible to the trainer and they give us indications how well a participant has been done. And then we can actually share with them valuable feedback. We have numerous environments that we created ourselves. We have worked with vocational schools to ensure they are targeted for specific safety education and training environments. Our usability, user experience, and net promoter scores are quite good. Now, summary and outlook. I'm embracing research together with industry. I cannot say it more. We need you guys. We are truly excited at the Technical University of Denmark, as well as other universities around the world, the many that you guys have in the United States or elsewhere in the world. It's currently very much focusing on technology and digitalization as the enablers. But I don't want to shy away from any of the safety management research that is happening, because the human factors and the work environment, there's a lot of things that are also still unresolved. I said already, your world is our laboratory. As much technology as we utilize, it's all about the humans in the end. Thank you very much.